Okay, for Unit 6, we're going to be talking about systems of equations. And so I want you to write down the definition of what a system is. It is two equations. So go ahead and write that down in your notes. Your notes should look very similar to mine. Two equations that share variables. That share variables. And most often, the variables are x and y. Okay, so we're talking about two equations that share variables. So when you think of a system, when we're talking about systems of equations, we're talking about two of them. And they have to have the same variables like x and y or a and b or whatever it might be. Second thing is a solution. When we're talking about a solution, we're talking about the point. Go ahead and write that point. The point where two lines cross. And usually that point looks like this, a coordinate x comma y. Another word for solution would be a point of intersection, point of intersection. So another word for solution is point of intersection. And I'll actually show you what that looks like. You're going to have to use this today in your discussions as well as in writing. So it's important that you write down these terms and write down the definitions. If you need to, you can pause the video and go ahead and copy them down. Okay, so let's talk about when it says it's a system of equations and you end up with one solution. So say, for instance, I graph an equation on the line. So I graph the first line. And then I graph the second equation. And maybe the second equation looks like this. And I am looking for their point of intersection, or what we call their solution. In this case, they only touch one time. They cross one time. So their solution, or their point of intersection, would be in the form of a point, x comma y. Okay, so how I do that is I start at 0 and I go over to the x and up to the y. So I went over 2 and I went up 3. So my point of intersection, or my solution, is 2, 3. And we say this system has one solution because they only cross one time. Okay, let's talk about this type. What if it has no solutions? Well, a solution means they have to cross. So if it's no solutions, that means that they don't cross at all. For instance, well, let me draw this one and then I'll show you what I'm talking about. Something like these two lines. These are what you call parallel lines. They'll never cross. So you have no solution. There is no point where they ever intersect. And I wanted to show you guys a couple of things. I'll talk to you about equations in a minute. But for this infinitely many solutions, we're going to talk about, okay, well, one solution is they cross one time. What does infinitely many look like? Because that's a big difference, infinitely many. Infinite means it goes on forever and ever and ever. Okay, so if infinite is more than one, then what does that look like? Well, say for instance I graph an equation and it ends up looking just like this. And the next equation that I graph is the exact same equation. So I graph the second one and it's the exact same one. The reason why we say they have infinitely many solutions is because this line crosses over and over and over again. It touches the other line underneath infinitely many times. It just keeps crossing over it because it's one right on top of the other. Now let's talk about what the equations would look like. Okay, so with these solutions, we can also talk about their equations. And I'm not sure if you guys remember, but when we were graphing equations before, we would talk about them in the form of y equals mx plus b. And b is the y-intercept, and then m was the slope. So for one solution, when you graph these two equations, they're going to have a different slope, so a different m, that's what you have on your paper, and they're going to have a different, oops, I almost forgot the e here, and they're going to have a different b, a y-intercept. So one solution, the equations look completely different from each other. Whereas no solution, the slopes actually look the same. So they have the same slope, the same m, but they have different y-intercepts, a different b, different y-intercept. So in this case, their slopes, their m will be the same, but their b's will be different. And this will make more sense too when you actually start graphing the equations or even looking at the equations in order to graph them. And the last one, when they're infinitely many, that means they're going to have the same m and the same b. So the same slope. So this is going to be the same and this is going to be the same. If you need some extra time to write this stuff down, just go ahead and pause it, rewind, fast forward, whatever you need to do in order to get all the information.